So we will continue with the nucleophilic addition to carbonyl carbon. We have talked about the carbon nucleophiles, oxygen nucleophiles. Now we will move on to nitrogen nucleophiles. The first reaction is called imine formation. This is the reaction between the carbonyl aldehydes ketones with a primary amines. So here is the reaction. The primary amine, the nitrogen, will attack on the carbonyl carbon. And after dehydration, it gives a CN double bond. This is called the imine. We will talk about amines more in detail later in chapter 23. But here I do want to give a brief introduction on the classification of amines. Primary amine refers to the compound that has only one carbon attached to the nitrogen. So you are going to look at the nitrogen. This is different from classification of alkyl halides or alcohols. For alkyl halides or alcohols, you are going to look at the carbon where the OH or the halogen is attached to and see how many carbons are attached to that carbon. But here, you don't look at the carbon, you look at the nitrogen. So for secondary amine, there will be 2 carbons attached to the nitrogen. And the tertiary amines, there will be 3 carbons or 3 alkyl groups attached to the nitrogen. All right. So back to our imine formation. Let's take a look at the mechanism. The first step in the mechanism is the nucleophilic addition of the primary amine to the carbonyl carbon. This will break the CO double bond and give the tetrahedron intermediate. And the next step will be a proton transfer. So the positively charged nitrogen will give its proton to the negatively charged oxygen. That gives the neutral tetrahedron intermediate, and this completes the nucleophilic addition step. The second stage is the elimination reaction. Elimination of water from this tetrahedron intermediate gives the CN double bond. So some base, it could be the amine, it could be water molecule that will grab the hydrogen on the nitrogen. Double bond forms and OH leaves. Okay, so that's how the double bond is formed, but this is a CN double bond. So elimination, this more specifically, this is a dehydration, right? And it gives the imine as the final product. We have a specific name for the tetrahedron intermediate. It's called carbonyl amine, which means on the same carbon we have an OH and also an amino group, a nitrogen, attached to it. So one carbon atom has an H and one carbon atom has an oxygen and a nitrogen. That's called a carbonyl amine. It's not stable. It will have an elimination reaction. All right. So imine is the final product. So what will be the product from the reaction of acetaldehyde and benzoamine? So the nitrogen of the amine will attack on the carbonyl, and eventually it forms CN double bond. That's the product. Okay. it's called ethylene benzoamine. The nomenclature for the imine is not required. And here is the carbonylamine intermediate after the primary amine attacks on the carbonyl. Next example, we have benzaldehyde and ethylamine. The product will be an imine, carbon-nitrogen double bond. All right. The next reaction is called enamine formation. The only difference between imine and enamine formation is that in the imine formation we have primary amines, while in the enamine formation we have secondary amines. The product enamine here has a CC double bond, and one of the carbon has a nitrogen attached to it. Okay, so it's called enamine. It's similar to the enol when we have OH attached to a double bond. Here we have a nitrogen attached to the double bond. All right, so for the mechanism, the first few steps will be exactly the same. Nucleophilic addition of the nitrogen to the carbonyl carbon. It gives tetrahedron intermediate. The next step will be proton transfer to give the neutral tetrahedron intermediate. All right. Now, in the imine formation, we have a dehydration reaction, right? The H on the nitrogen is removed to give the double bond, and OH leaves. But now we don't have an H on the nitrogen. So what will happen here is the lone pair of electrons on the nitrogen will be donated to the carbon to form the carbon-nitrogen double bond, and OH will leave. Now we have a carbon-nitrogen double bond with a positive charge on the nitrogen. Then the hydroxide will take the proton from the alpha carbon to form a CC double bond. At the same time, the CN double bond will break and the electron will go to the nitrogen to neutralize the positive charge. This gives the final product, the enamine. All right. So here we also have the carbonylamine as our tetrahedron intermediate. And the final product is enamine. So the last step, water is removed. This is still an elimination, but the hydrogen is removed from the adjacent carbon atom. The reaction between a carbonyl compound with a secondary amine forms enamine, and the secondary amine that are used will, in most cases, it will be a cyclic amines. Okay, such as the example here, we have pyrrolidine, which is a secondary amine. So the product here will be N1-cyclohexenolpyrrolidine. So we have the double bond in the 6-membered ring, and the nitrogen of the pyrrolidine is attached to one of the double bonded carbon. And this product is an enamine. Alright, the intermediate. This is the tetrahedron intermediate after the nitrogen of the secondary amine attacks on the carbonyl carbon. Then it forms the carbon-nitrogen double bond. Then the hydroxide will remove the proton on the alpha carbon. So the CC double bond is formed. Okay, so that's how the enamine is formed. The imine and enamine formations are reversible reactions, which means they can be used as protecting groups for carbonyl. Previously, when we talk about the protecting groups, we used acetal or ketal to protect carbonyls. Now you know for all those reactions using acetal or ketal as the protecting group for carbonyl, we can replace the acetal or the ketal with imine or enamine. Alright? Second, both of these two reactions are very important to biochemical processes. Since amines are one of the most abundant natural products, and they are also present in our body, and carbonyl compounds as well are present in our body, and the reactions between amines and the carbonyl compounds in a lot of cases will start with imine or enamine formations. Hopefully in the biochem course that you are going to learn next year, you will see some of these reactions. The last reaction for nitrogen nucleophile is the hydrazone formation. The reaction between the ketone or the aldehyde carbonyl and hydrazine, NH2NH2, will give hydrazone as the final product. This reaction mechanism is exactly the same as the one for the reaction between carbonyl and the primary amines. Hydrazone has very special characteristics. Lots of them are solids and they are crystalline. So this reaction, it's an addition of hydrazine to carbonyl, and it's used to characterize aldehydes and ketones, because aldehydes and ketones are, in most cases, liquids. So they are not easy to characterize years ago, before the modern instrument were invented. So about 100 years ago, people will make hydrazone from aldehydes and ketones, so they can take melting points to verify it is the product they want.